Welcome to the session on direct memory access. Accessing memory directly sounds appealing. Let's try to understand the concept. We know that there is a latency or delay in the speed with which CPU executes the instructions and the speed with which the memory device serves CPU. This gap in the speed leads to a wastage of CPU time or cycles while interacting with the memory device like hard disks, especially for data transfer. Can we have some strategy to overcome this problem? Certainly yes. One of the most basic techniques is to let CPU to offload intensive memory access tasks to another component called DMA controller. This approach then frees the CPU from these memory-bound tasks and provides more cycles to CPU-bound tasks for which it is better suited. But what is a DMA controller? Simply speaking, DMA controller is a special purpose processor which is used to ensure the completion of the I/O request with least intervention of CPU. But how this coordination between CPU and DMA controller happens? Good point to explore. Let's consider a scenario. Say we want to input large amount of data from a device, say a DVD reader. To execute this memory access by DMA mechanism, the operating system configures the DMA controller with the address of the source, that is the DVD reader, the initial memory address from where input has to be taken, and total number of bytes to be input. Once configured with required information, the DMA controller would notify the CPU to release its control over the data bus to access the DVD reader directly for read purpose. This mechanism of stealing the data bus from the CPU and using the data bus for the data transfer between the memory and the I/O devices is called as cycle stealing. Once the DMA controller gets control over data bus, it reads the device, that is the DVD reader, for the total number of bytes to input. So what happens once the data transfer operation completes using DMA? At the end of the data transfer, DMA controller generates an interrupt request to intimate the CPU about completion of data transfer. Such interrupts indicate completion of data transfer, and hence the CPU will take back the control of data bus, which completes the direct memory access. Let's summarize the steps. Initially, DMA controller requests data bus control from CPU. Identifying a memory read request, the CPU grants the data bus control to the DMA controller and resumes to some other critical task. To this, the DMA controller acknowledges data bus grant to CPU. Finally, DMA controller reads device and writes to memory. At the end, the DMA controller generates an interrupt request to tell the CPU